we want to do some simple thing, that is a decentralized text editor. And we want to do it on this internet.over-NDN. And this talk is about what are the so-called technical roadblocks we have encountered and what kind of, because we are not living in a very ideal world, we have to make some compromises. So with those technical roadblocks, what are the so-called required compromises we have to take to make this application work? Then we move back to the beginning of this session, then only to say how NDN provides a different approach, only to simplify our application. So we need to first figure out when we are talking about decentralization, what we are really talking about. For example, recently we have seen a trend of moving servers out of the cloud. For example, if I assume most of you guys here have used Overleaf before, if you don't know, Overleaf, you can even self-host an Overleaf server on your own. But the situation is that really called a decentralized so-called text editor, also for social media. For example, Mastodon, you can so-called self-host a Mastodon instance. Is that really a decentralization you want? For example, Overleaf, you self-host a server. Sure, you still don't change the communication model. That is, you have user and user TLS the server, data stored on the server, and you learn other data from the server too. But think about if I self-host the Overleaf server, I still control the things. I can modify I can in the back thing, log in my control panel and kick people out. Maybe that's not the right decentralization model we are trying to achieve. Later, people invent some other mechanism, the so-called end-to-end encryption. For example, WhatsApp, Signal, or other things developed recently. If you are familiar with the recent exchanges in IETF, you may also heard another thing called message layer security. They are all emphasized on so-called end-to-end security, end-to-end encryption directly between users, so-called directly between users and users. If you have a key, I have a key, we somehow authenticate each other, then we can negotiate a key to encrypt our data. Data itself is encrypted and signed because we have our own key. Then data can be stored in the server, or server deliver our encrypted data to each other's. Some server may say there's so-called retention period. Data stay in the server for some time, but data itself is so-called secure. Server cannot peek into the content of the data. But is it really the ideal story? For example, the overall assumption here is everyone have a key and we have identity. But essentially, at the beginning, how you authenticate the key, how you actually bind that authentic identity with the key itself. You still need some server in between that's to say, hey, you are the owner of this key. And still, the server can deny your communication. You want to send a message, say to Beichuan, but the server can deny you. You are not allowed to send a message anymore. Server is still in some sort of control because server can still see which particular key identifier is sending message to what particular key identifiers. So that triggers the discussion about what is the so-called the most wanted decentralization model by ourselves. I think we should think about interpreting decentralization as decentralizing the control power back to users themselves. Think about in an ideal case, every user has a key and it has identity. Those identities can be directly used for communication. We directly communicate with those identities on the internet, and among us, there's no third party. We just in between just the network for the packet. That's it. For the packet for us and the data end-to-end encrypted. So this is the effect we want to achieve when trying to build this application. And later slides will tell you what we have found. So to begin with the story, this is the effect we want to achieve. And first we think about, we have a key, and we want to send a message to two of the others in the network, so-called in the so-called text editor workspace. The two questions at the beginning is who is the other guy? How I name that? What is the identity of that one? Also, where is that guy? Because we know to this internet are doing with addresses. So we need to solve the two problems, user identity and addressing. And actually, the user identity is the prerequisite of the whole of communication, because address itself doesn't say anything. You have to know who you are talking to before you actually so-called connect to a specific IP address with port numbers. If you have identity part down, if you have addressing part down, after so many of years of internet development, we have pretty good idea on how to encrypt the connection. So connection encryption is the easiest one. But the biggest one is how to solve the identity problem. But the sad reality is there's no anything, there's no thing we can use. For example, we have some so-called identities. We have identity providers. We know Google provides some Google-based identity. Microsoft provides its own identities. And in academia, there's a thing called ORCID. And those kind of things basically have identity provider in between. Say, if you want to authenticate with another one, you have to talk with identity provider first, and that essentially become third party, become intermediary in our communication. Also, those identities cannot be directly used for communications. For example, if you have heard of certificate called email certificate authorities, theoretically speaking, can issue so-called email certificate, but I'm not sure how many of you have an email certificate. And also, people talk about the GPG case or PGP case. Those kind of keys, they are still keys, and you may bind some names with it, but still they are not directly usable for communications. Today, the sad reality is that either you go with so-called identity providers with Google, or you have to use your email address. That's like how we invite people into the workspace. But email address, it has its own problem. That is, the identity itself still subject to the service provider's control. For example, we know who runs the biggest email service in the world. It is Gmail. Gmail, ideally speaking, or theoretically speaking, can still so-called control your identity, can still kick you out from logging the email address, from logging the email service. So the two things here is not many identities that we control, user control, and second, none of the identity can be directly used for communications, and that is the situation we want to avoid. But this is a reality. We have to live with that. So the decision we made is, if we have to pick one, we pick the one that today's people are dealing with. Today's people are using identity providers for basically every technical solution. And this is the sad reality we must live with. So for identity, we have to live with it with identity provider. And the second problem is, given after you have an identity, how you discover the address for it. For that, you still need a mapping. And you still need a directory to maintain that mapping, to say for this particular user identity, what is the identity connectivity identifier for this identity. Then we still want something like more user control-ish, less third party. So we pick DNS as the so-called directory, because if you really control a service, if you really control a DNS domain, you have at least more control of so-called DNS records. You can edit DNS record there. At least this is so-called, we have more control power compared to a random server. So for here, if we still have the same assumption, saying the workspace owner controls DNS name, and if we want to authorize Varun into the system, we say, I tell the DNS provider to say, this identity Varun is authorized to add a DNS record in this DNS database. Then Varun, he will discover his own IP address and port number and try to edit DNS record in the database. And DNS provider will have to authenticate Varun with the identity provided by the identity providers. After discovering address, we can do secure connections. We are doing this by UDP-based TLS, DTLS, but overall, this is the bizarre picture we're ending up with. That is, although our so-called ideal picture is that everyone has a key, and we just do secure connection between the users, but we end up with this huge red box here. we have to rely on identity providers because there's no other solution that we can use to directly communicate. We have to rely on some so-called net traversal utilities because in today's network, the real peer-to-peer connection become more and more invisible. We have to rely on some external tools to help us establish a connection. And we have to use DNS to map the identity name to its IP address, and we have to rely on certificate authorities because otherwise, how you connect to any of the service on the internet. Looking back, this is the bizarre end result we are ending up with. And this is the ideal effect we want to achieve. What makes a difference? I think the biggest difference is still on the identity part, because on today's internet, as we just spoke, there's no so-called global established identity standard which provides a well-regulated namespace. The best thing we can use is, you can say it's DNS, but DNS is not that regulated per se. And for those so-called ad hoc solutions offered by identity providers or other things, or email addresses, those identity cannot directly use for communications because communications on today's internet are address-based. So you have to maintain a mapping between the name and the address. And even you do that, today's so-called user-to-user communication is still broken because you have firewalls, you have middlebox, if everything in between that's restricting or preventing people doing peer-to-peer connections. Those has really become the so-called technical roadblocks if we want to push decentralization onto this internet. Because even if you want to do decentralized apps, there is no so-called user identity that you can make use of that really decentralize the control power to users themselves. The so-called protocol, like for example, this OpenID Connect has a role called identity provider in the picture. And the sad reality is you either go with identity provider or you go with email address. And email address, we know it has its own problem. Also, we talk about end users, they cannot directly connect to each other and talk because we have all the middle boxes. We have to deal with those firewalls, and you have to build some relays by yourself. And those kind of middle boxes or intermediaries, they are the potential control points of a decentralized application that you want to build. So looking back, the original internet is quite so-called decentralized. You just have end-to-end IP reachability. The only bad thing, or one of the bad things, is it has no security at the beginning. After many years of development, you can still think that today's routing plan is still decentralized. We still have a bunch of autonomous systems, and they are not controlled by few providers. The routing plan is still decentralized, but applications, they are quite centralized into some so-called providers. In the name of, although I think the economic factor is still the driving force, but the technical reason of those centralizations is because security. And there's a negative feedback loop here. Say initially, we know address itself does not say anything, so people place middle boxes, firewalls in the network to block you from so-called malicious connections or block you from reaching to others. So you have to talk to a server or talk to the clients or talk to the cloud or application server to get your job done. Then network providers may think, now everyone talks to the server. How on earth? What is the incentive that you make peer-to-peer connections to others? So they put stricter firewall policies in the network. So there's negative feedback loop there, all because of there's no security in the original IP design, and that's the technical reason of why we ended up with this cloud centricity of building up applications and so-called ad hoc security solutions in today's network. So looking back on our development effort on Only, I would say we still spend a amount of efforts to make the application run because we know NDN code base is not that mature. We spend a lot of time to debug things, but we haven't really troubled by the two technical roadblocks, the user identity and the connectivity part, because NDN is already using a different network model, that is named entity with trust relations produce and consume data. That means whenever you so-called bootstrap in a network, you must have a name first. And the network itself is already name-based. That means you already if you join a network, you already have a name first. We can safely reuse that name as we have presented in the workspace talk. We can safely reuse that name for application purposes. For example, if I use my email address to get authenticated in a bootstrap in a testbed network, I already have a name cs.ucla.edu/Tianyuan, and this is a name that can be directly used for communications. I can put my data under this prefix, and others can directly fetch it. And as workspace owner, we merely invite this email address into the workspace, and we can have naming conventions to ensure the binding between the original so-called user identity on the network and the real user identity in the application scope. For connectivity, NDN testbed already provides us this name-based overlay, so we don't need to tackle with the so-called firewall or mailboxes issue on our own. It is testbed operators dealing with those, fixing firewalls, connecting local operators to say, hey, what's going on there? Please let our connection, please let our communication go in, please open this port number. And also, think about if you already have this name-based overlay, so like this, we don't have to fix the so-called peer-to-peer connection between a user in US and a user in Europe. Testbed already provides this overlay for us. We merely just utilize this to build our application and provide communications of so-called data delivery service for us. So in summary, I think the best way, or our take of building decentralized application, is to use direct user-to-user communication. That is really decentralized first, because you really need to decentralize the control power back to user's hand. And if you go that way, you may not have intermediaries or any third party, except the network service between users and users. You want the communication direct between users. In this effort of developing a decentralized text editor onto this internet, most of our hassles are because of the two roadblocks, because there's no so-called real user identity that can be directly used for communication, and peer-to-peer connections become more and more feasible. We have to dealing with firewalls, mailboxes, all kind of things. And on the only side, users, to some extent, they already have an internet name, which is their email address, but you still control the key of your identity that can be directly used for communication. And also, testbed provides this name-based overlay for us. So the so-called connectivity merely becomes layer 2. As application developer, we only need to care about how user reach the first so-called hop, that is the testbed router. We only need to deal with that. And how this packet traverses through the global internet, the current so-called legacy internet, this is testbed job. Testbed operators need to fix that. We don't need to deal with that. That save us a lot of time.